thought it'd be nice to do a few questions together to wrap up the first 4 sections out of chapter 4. So, like usual, I've got a set of true-false that I'd like you to look at. And the spirit behind this, should be enough time for you to capture this and do these problems at your own convenience. I'm going to ask you to hit pause, screen capture this, do whatever, and then I'm going to go ahead and show you the answers. Oops. There it is. And of course, the spirit is to try these ahead of time before you check your answers. All right, so there's our true-false from the second 2 sections. And I've got 3 cool-down questions from the last 4 sections I'd like us to look at. And the spirit's the same. I'm going to give you the question and ask you to pause, try it on your own, and then I'll show you the solution. So here's the first one. If I've given you a matrix A, I row reduce it for you. So given that information, I'm asking you to find 2 things. The column of A, and what's the basis for the column. When I say the column A, we call that, it's the subspace of R2, which is the column space. All right, hit pause, and now I'm back. And here we go. What is the column space of A? Well, because of this reduced matrix, I can tell that there's 1 pivot, and so that tells me the first column of A is all I need. You can see that the second column is really unnecessary. I don't need it. It's just the first one doubled. So the column space of A is the span of that first column vector. And again, the span is all the linear combinations, which is kind of an overkill. It's just all the scaled versions of that single vector. Then, what's the difference between that question and the second? Well, the basis for the column space is just that single vector. And so you don't put the word span, but you do use set notation and you show it like this. So they almost look like the same answer, but I asked this just so we know that there is a slight distinction between those 2 questions. The basis, what gives me all of my column space, is a single vector. And the entire column space is the span of that vector. All right. Second one. Let's switch to null. This time I've given you a matrix B. Looks like it's already been row reduced, so it is what it is. And again, asking you 2 similar questions. So hit pause and try that all by yourself first. And here's the solution. Well, for the column space that we saw above was pretty friendly. You can spot it just visually from the original matrix and the reduced one. The null takes a little more effort. We know it usually involves calling out some variables. Imagine this was augmented with the 0 vector. The first thing we call out are my free variables. Looks like there's just 1, and it's x2. If I were to call out that second row, that looks like it's saying x3 equals 0. Again, imagine a column of zeros here. And x1 is positive 2 x2s. So we usually unscale x2, left with 2, 1, 0. So, to answer the first question, what is the null space of matrix B, is, again, the span of that single vector. What is the basis for the null of B? It's the set that contains that single vector. All right, third example. We're told these 2 vectors form a basis for R2. And we're asked to find the coordinate vector that helps us find the target vector that you see here. Again, hit pause, and here comes the solution. So remember what's going on here. We have a new basis for R2. The original is my standard basis, 1, 0, 0, 1. But any two vectors in R2 can form a basis as long as they're not scalars of each other. And so we're solving this matrix equation. I know my matrix. It's just formed by those two new basis vectors. We don't know this. That's what we're trying to solve. But I do know my target vector, which is negative 22, 15. And that just gives us the familiar augmented matrix. We're going to solve this either by hand or grab a calculator, and we end up getting so clearly my coordinate vector is my final column 7, negative 3. What does that mean? That means if I were to take 7 of that first column and minus 3 of that second column, we would get for a moment negative 7, 21 plus negative 15, negative 6 for a final vector negative 22, positive 15.